Okay, so this is the last section. After this section, we will have an actual a test. So not a quiz, but a test. And so do want to make sure we're figuring out the skills that we need. And so this is something that I know that we did not get to, and usually in sophomore chemistry, sometimes we do, sometimes we don't. But this is a molarity solutions concentration. So I'll spend a little bit of time here and show you some calculations. So let's start with our definitions for a solution. So solution is something that's going to be dissolved in something else, and so solutions can be they can be liquid. All right, so you can have a liquid solution, and that's pretty standard stuff, right? So that's like a sports drink, so Gatorade, um, a soda, a pop, a Dr. Pepper, something like that, something that has something dissolved in water. So liquid solutions are particularly common. Then uh, you have the gas solution, and so a gas solution um, is something where you have gases that are together. So kind of a gas solution. So you have something like air, and then we can have a solid solution, and that would be in some kind of alloy, so a metal alloy. So um, something that's not on the periodic table. So like brass is not on the periodic table, right? That's an alloy. Bronze is not on the periodic table. So something like that. So something that's a metal that you don't see on the periodic table means it's a combination of metals. And so we normally deal with the liquid solutions, and so that's really the most common. So liquid solutions are the most common for us. Let's take a look at our definition here of a solute and a solvent. So a solute and a solvent are very simple. The solute is what is dissolved. So let's get the pen here. There we go. So the solute is what is dissolved. So maybe in our sports drink here, maybe you have some salt, right? Some sodium chloride, and so that would be a solute. Now there's more than that, like there's sugar and potassium chloride and other things, but that would be a solute because it is being dissolved. And so what is dissolved? And so the solvent, it does the dissolving. So it does the dissolving, or it 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 basically surrounds the thing that gets dissolved. So it's going to surround the solute. So if you ever put like a bunch of sugar into your milk for your cereal, and you're like, oh, my cereal, it's horrible. It's Cheerios, and I don't like them. I'm going to add some sugar because I really wanted like Captain Crunch. Well, when you add that sugar, you've got your bowl here, right? And it's got the milk in there. And so what happens is that the milk is surrounding the sugar. And so what happens is when you run out of milk to surround the sugar, meaning that we don't have any milk left over, well, what happens? Well, we know what happens. The sugar accumulates on the bottom of the bowl, and it is just that nice sugary sludge at the bottom, and that's because there's no milk to surround it. And so the solvent or the milk is surrounding the sugar, and when you run out, then there's nothing else to surround. And so if you just keep adding and adding and adding the sugar, it just goes to the bottom. So those are some ideas on solute and solvent. So let's talk about the um, let's talk about the idea of concentration. So the idea of concentration is this: that you're comparing your solute to your solvent. All right, so you're comparing the solute to the solvent, and so that's what concentration does. But we have a very specific one that we use here in the chemistry class, and that's molarity, and that's going to be a capital M. So molarity is the one that we use, and because we use a lot of solutions made of water, molarity, capital M, is moles of solute divided by, so it's a math problem, liters of solution. And then we basically simplify that down to molarity, capital M, equals moles over liters. This is an extremely useful formula, and we will use it quite a bit. All right, so that's an extremely useful formula, and so molarity is measured in values with an M at the end. So like our concentrated hydrochloric acid is 12 M. So 12 molarity. That's the stuff I get from the chemical supply company. So 12 molarity. So like when I give you the hydrochloric acid to use in class, I dilute it, and I might give you, let's say, 3 molar, or like 1 molar, or maybe 0.5 molar. And so the smaller the number, the more water you have. Okay. Here's the way the IB writes it. I prefer the way that we learn it here. Molarity equals moles over liters, but this is the same thing. C is concentration, N is moles, and V is volume, right? And so it's the same thing. It's just using some slightly different variables. And so concentration equals moles over volume is the same thing. So that's the same thing. Okay, let's slide down here, and let's look at this formula here. This is concentration times volume equals concentration times volume, and I usually just rearrange it to molarity times volume equals molarity times volume. That's called the dilution formula. That's the dilution formula, and this is the formula that I use to make all the solutions in class. So I use this formula. It's called the dilution formula. So I'm diluting a chemical. So let's go ahead and do one of those real quick. One of the ways you know that you need the dilution formula is you would have a problem that's saying, how would you prepare? So if you see the word prepare, it's almost always a dilution formula. So we're making a salt water solution. So we've got some salt over here, and we're going to put it in a solution. So we're going to add some water. So it says, how would you prepare a 100 centimeter cubed of a 0.1 mole DM3? So right away, we want to look at this and be like, okay, that unit right there means moles are on top. It means the decimeters cubed are on the bottom because it's a -3, and a decimeter cubed is the same thing as a liter. And so mole DM minus 3 is the same thing, and you guys really want to know this. This is the same thing as molarity. All right, so that is something that you want to know, because you do not want to get confused and think the mole DM minus 3 is something that it isn't. It's just molarity. Okay, so this here, what the heck is that? Well, hopefully you remember that a centimeter cubed is the same as a milliliter. Okay, so that's going to help us out. So we want to make this, how would I prepare this? And so I think I misspoke. I think I said we were going to use the dilution formula, and that's not correct. We're not going to use the dilution formula on this one because, there's only one set of data. The dilution formula is if we have a third piece of data. We only have 2 here, so we're just going to use the molarity formula. So we're just going to use our molarity formula here. Just going to use that guy. So molarity equals moles over liters. Well, what do we have? We have molarity. So we have change the color real quick. We've got 0.100, and that's going to go for molarity because remember we said that that unit is molarity. And we have to find moles, so that's going to be on top. That's going to be our X. So let's go ahead and swap that out with an X. And on the bottom, we have 100 milliliters. Now the problem is that milliliters and molarity do not work together. Okay, those units are not going to play nice because remember molarity is moles per liter, so we need to convert that to liters. So let's convert that to liters real quick. So let's make it 0.100 liters. I just divided by 1,000, and so then that would be a better unit. So let's go ahead and put that in there. And so we're going to go 0.100 liters. Okay, so now molarity and liters can play nice because they both have the liters in them. So we're going to solve for X. So we're just going to multiply those two, and we're going to get a value, and that's going to give us moles. Okay, so we're going to get a value in moles, and it's going to be 0.01 moles of NaCl. So how would I prepare this? Well, I've got to put in some moles, but I want moles. We can't measure moles in class, so we're going to want to convert this over into grams. So we're going to do that real quick. 0.01 moles NaCl. And let's convert that into grams. So 1 mole on bottom. I'm kind of running out of space here, so that doesn't look particularly great. Let's clean that up real quick. Times 1 mole. And we're going to add up sodium and chlorine. So we get our handy periodic table out. And so we're going to do 22.99 for the sodium. We're going to add to the chlorine 35.45. And we're going to get 58.44. And we're going to run that through. Apply that, 0.01 times 58.44, and we're going to get 0.5844 grams. And so change the color real quick, and it's going to be 0.5844 grams of NaCl with enough water to get 100 milliliters of water. So with 100 milliliters of H2O. Okay, so I know that's kind of messy. I'm running out of time here on my video, so let me erase this real quick. So it's basically with enough water to get to 100 milliliters of H2O. So in your container, you would add that much grams of salt